Question 1 on the calculator paper was about arcs and sectors, and you'll note that you're given information on the radius, which is 3, and the angle here, which is 1.3, and that is given in radians. So it is very worthwhile making sure that your calculator is in radians at the beginning, otherwise you could go a little bit awry from the off. Once you've got that, in part A, we are asked to find the length of arc ABC, which is this length here, and in order to do that, if we've got an angle in radians, we can just use the formula that arc length is just equal to r theta, where r is the radius, which we said is 3, and theta is the angle in radians, which we've got here, which is 1.3. So multiply that out and we will get 3.9 centimeters. For part B, we are asked to find the area of the shaded region, which is this area here. So, to find the area of, there's broadly two ways you can do this. So the way which I'm going to do here is I'm going to calculate the area of this sector here, and then I'm going to subtract that from the area of the complete circle. So the area of the sector here, we've got the formula in our booklet, which is half r squared theta. So that's going to be half times the radius, which is 3, multiplied by theta, again in radians, which is 1.3. So this is going to give me the area for this sector here, but I'm actually asked for this area here, the region of this. So if I have the area of the entire circle, which I know is going to be pi r squared, and I subtract the area of this, I'll be left with the area of this section here. So pi r squared is going to be pi times 3 squared minus, so this here is the area of the whole thing, this here is the area of this, so if I subtract this area from the entire area, I'll be left with the shaded region here. And if you plug that into your calculator, you should get an answer of 22.4 centimeters squared. You can, alternatively, work this out just using this formula. So if you do half r squared theta, you can work out the major sector here, and if you just put in half times r squared, so r is 3 squared, and then if you recognize that this angle is going to be 2 pi minus 1.3, then you could also just plug that straight in, and that would also get you there. But I think it's arguably easier to visualize if you work out the area of this and subtract it from the area of the circle, although this one is more efficient.